This is the formula that we use when we are calculating Spearman's rank coefficient of correlation for repeating ranks. The first step we do is to rank the values of X and those ones of Y independently. If we start ranking the values of X and we rank them from the least to the greatest, from the lowest to the highest, we shall have the least being 65, and that will be ranked 1. Then followed by 80, which will be ranked 2. Then after that, we shall have 90. You realize there are two 90s here. We have this 90 and this one here. So one of them will take rank 3, another one rank 4. Take those ranks, add them, divide by 2. 3 plus 4 divided by 2 gives us 3.5. That means each of the 90s will be ranked 3.5, like that. The next number after 90 is 95. That will be given position rank 5 because we have utilized rank 3 and 4 in coming up with the rank for 90. So the next rank is 5, which will be attached to 95. Then the next one after 95 is 100. You realize there are 200s here. There are 200s here. There's this one and this one. So one of them will be ranked 6, another one 7. Take the two ranks, 6 and 7, divide by 2 because there are 200s. You will get 6.5. That means this 100 will be ranked 6.5, and this other 100 will also ranked 6.5, like that. Now we have utilized rank 6 and 7. The next rank is 8, which will be for 120, and then 150 will be given rank 9. When we are done with that, the next step is to rank the values of Y, the values in column Y, from the least to the greatest. If you rank these ones from the least to the highest, that's what you must do here. So the least value here will be 90. So the ranks will be as follows. The least value is 90, taking rank 1, 95, taking rank 2. Then the third value, or the third highest value, the third lowest value after 95 is 100. There are 3 of them. We have this, and this. So one of them will be ranked 3, another one 4, another one 5. Add those ranks, divide by 3 because there are 300s here, so that you can get the average rank to use for each one of them. That gives you 4. That's why we have rank 4, rank 4, and rank 4. Remember we have utilized rank 3, 4, and 5. So the next rank is 6, which will be given to 106 because it's the next number after 100. And then we have after 106 we have 110, and there are 2 of them, meaning one of them will be ranked position 7, another one position 8. Add the 2 ranks, divide by 2. If you add rank 7 and 8 divided by 2, you get 7.5. That's what we have for 110 in each case. We have utilized rank 7 and 8. The next rank is 9, which will be ranked against 125. So that's how we do the ranking for X and Y. After that, you now come up with this column here, which represents the difference between the two ranks. We have 2 minus 4 giving us -2, 5 minus 6 giving us -1, 6.5 minus 7.5 giving us -1, all the way up to 9 minus 4 giving us 5. Then after that, we now square these values to get d squared. Remember, d squared is from this column squared. This is our d. So squared means we keep squaring these values to get the value right here. -1 squared gives us 4. -2 squared gives us 4. -1 squared gives us 1. all the way up to 5 squared, giving us 25. When we are done with that, then we now sum this squared, and we shall get summation d squared as 103.5. The next step now is to do the actual calculation, where we shall say rho, this one represents the Spearman's rank coefficient, will be given by the formula that we had indicated earlier alone, which is this one here. So that will be equal to 1, this one here, minus 6 into summation d squared is this one here, 103.5, plus 1 over 12 into, now what is this m1? M1 simply represents the first instance we are getting a number repeated. So the number that is repeated for the first time, or the first number that is repeated is 90, which is repeated twice. So we shall take 2 cubed, 2 cubed, 2 from the fact that the first number that is repeated has been repeated twice. So we take the 2 cubed minus 2 into, okay, you close the brackets and then plus 1 over 12 into, which is the other number that has been repeated. The other number that has been repeated is 100, which was also repeated twice. So we shall have 2 cubed minus 2. 2 cubed minus 2 from the fact that another number has been repeated twice. Then plus 1 over 12 into 3 cubed minus 3. Why 3 cubed? Because the other number that has been repeated is this 100, which has been repeated 3 times. So we take the number of times it has been repeated, which is 3, you cube it minus 3. And then the last number that has been repeated is 110, which has been repeated twice. So we shall have 1 over 12 into 2 cubed minus 2. So that is why we are having these numbers here. They simply represent the number of times our value has been repeated. So that simplifies to this one. When you perform this, you realize this will be 103.5 plus 1 over 12 into 8, 2 cubed minus 2 all the way up to there, over the denominator, which is the number of pairs of observations, which are 9. We have 9 pairs of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 cubed minus 9, and then that simplifies to this one. Remember, here we have gotten the powers of, okay, the cubes. 2 cubed is giving us 8 minus 2, and then 2 cubed is giving us 8 minus 2. 3 cubed is giving us 27 minus 3, and then 2 cubed is giving us 8 minus 2. So that's what we have done here. And then the next one is actually a simplification of the whatever that is in the brackets. We have this one giving us 6, this giving us 24, and this one giving us 6. The denominator is 729 minus 9, because this is 9 cubed minus 9. And then that gives us this. So that's after we have multiplied this by this, getting us 0.5, this by that, giving us 0.5, this giving us 2, and this 0.5. Then you continue downwards until you get 0.1083 as the value of our rho. So that is how we calculate Spearman's rank coefficient of correlation for repeated ranks. Thank you.